Hi guys, so I've had a few emails about finding the worded questions task quite challenging. So I was just going to go through a couple of them and sort of show you what you've got to do, and show you it isn't actually that much different to what you had to do before. So if we look at the first one, we've got a ladder against the wall. This is a really common maths problem with trigonometry, ladders going up against the wall. It asks you how high up the wall will this ladder reach, and how far away is the distance is the base of the ladder from the wall. So you've basically got this triangle with 6 as the hypotenuse, 34. So if I drew this out further down, so this is question 1, if I draw this out where there's a bit of space, you've got the wall, you've got your triangle, you've got 6 was the length of the ladder, so that's the length of the ladder, and you've got 34 as the angle between the wall and the ladder, so that's 34 degrees. Part A was saying how high up the wall it is, so for part A we're going to have to find the length of this side. Then you just do what you've been doing all the time, so you label your sides, so you've got adjacent and you've got hypotenuse, so you've got A and H, so that's going to be cos, so cos theta equals A over H. Cos 34 equals adjacent x over hypotenuse 6 times by the 6 on the other side, so 6 times cos 34 equals x. Type that into the calculator and get an answer of 4.97 or 4.97. So that's the height up the wall that it reaches. So that's for 1A. For 1B, what you do here for 1B is it's saying how far is the base of the ladder. So the base of the ladder would be here, the bottom of the ladder, from the wall. So you're finding the length of this side. So for 1B, you're trying to find y. If we label the sides again, so you've got from 34, this would be the opposite. We've got the hypotenuse already as 6, so we can use opposite and hypotenuse for sine. So sine theta equals opposite over hypotenuse. Sine of 34 equals opposite, which is y, divided by your hypotenuse, which is 6, times the 6 to the other side. So 6 times sine 34 equals y. Type that into a calculator and get and you get 3.36. So that's how you do question 1. It's just try and draw out the triangle if you want to, because it's quite sort of small up here. It's quite small to label anything. So maybe use a scrap piece of paper to draw out just a triangle. Let's do, if I do question number 3, I'll just do a few of the odd questions. So question number 3, you've got the height of a tree and the distance x, xy. So you're trying to find the height of the tree, so you're trying to find this length here, and a distance of x to y. So a distance there. So for this one, let's just draw out the triangle again. So draw out the triangle. The height of the tree, you've got distance to the person, and then you're trying to find the distance x to y. Okay, so you've got in your question you're given 56 and 15. So that's 56 and that's 15 meters. It gives you x and y as well, so you know that that's going to be x and that's going to be y. Okay, so for the first part of the question, it's asking you to find the height of the tree, so that's the x there. Label your sides, so you've got your opposite, the angle, so it's across from the 56, it's across from the 56, so it's the opposite. And you've got next to the angle, so you've got your adjacent. So O and A, we're going to use tan. So tan theta, so this is for 3A, tan theta equals opposite over adjacent, so tan 56 equals x over 15, times by the 15, so you get 15 times tan 56. That is x, which equals 22.2. That's how tall the tree is, a 22 metre tall tree. Okay, for part B, it's saying how far is it from y to x. So for part B, you're trying to find the length of this line. Let's call that y. You've now got y is your hypotenuse. So you've got A, you've got your adjacent, and you've got your hypotenuse. You could use this one if you want, but it's better to use the one that they've given you. It's better to use 15, and it's better to use you have to use this one. So A and H, so you're going to be using cos. So cos theta equals A over H. So cos 56 equals adjacent, so 15 over your hypotenuse, which is y. Okay, this is one that's a little bit harder to solve. So times by y on the other side, y times cos 56 equals 15. Divide by the cos 56 to get y equals 15 over cos 56. 15 divided by cos 56 is 26.8. So the length of x to y is 26.8. So that's how you do question 3. If I do question 5 now, or question 5 is really similar to question all the rest, but let's do question 5, fine. The string makes an angle of 63 degrees to the ground and the kite is 46.5 meters above a point T. So let's draw out the triangle again. So we've got 63 and 46.5, so the angle is 63. And the height above T is 46.5. So the letters that you've got on it, on it don't really matter. The fact that it's called T, X and Y. So that's what you've got given to you in the question. It says find the length of string needed, which is X, and find the distance to the buoy, which is Y. So for the length of the string needed, you're trying to find X, about 90 degrees there. So X is your hypotenuse. The 46.5 is across from the 63, so it's going to be your opposite. So using sine, so sine theta equals opposite over hypotenuse, so sine 63 equals 46.5 divided by your hypotenuse, which is x, times by x, so x times sine 63 equals 46.5, divide by sine 63 to get 46.5 divided by sine 63. That gives you the value of x, which is 52.2. So x equals 52.2. So that's how long x is going to be there. So that's fine. That now you have to find the distance of the buoy from the point T. So find the distance of y. So for 5a, so that's 5a, 5b. To find the length y, y is your adjacent. It's next to it, next to the 63. So we've got opposite and adjacent. So we can use tan. So tan theta equals opposite over adjacent. Tan of 63 equals 46.5 divided by the adjacent, which is y, times by y, divide by the tan 63, and then put that into your calculator. So 46.5 divided by tan 63, and it gives you y is 23.7. So that's how you do question 5. If I just do question 7 now. So you've got two metal rods hinged at C. A and B are attached to a vertical wall, and it tells you that A to C is horizontal. So you've just got a wall that two things are attached to. It doesn't actually matter at all really what the problem is. It's more just trying to have a look at. You're just trying to have a look at the triangle really. Oh, that would have saved loads of time earlier if I'd have done that first of all. Okay, so we've got a triangle. Let's just get rid of some of the bits we don't need. We don't really need that at all. We don't need this on the roof. We've just got this. For question, it is trying to say, can you find AB? Can you find the angle BCA? So let's do A to B first of all. So if we want to find A to B, so this is 7A. A to B is this angle here. You want to find this side here. You haven't got any angles yet. So when you say, am I going to use sine, cos or tan, there's no angles to go off. If there's no angles, you've got two sides already. You've got one side, two sides. You're trying to find a third side. You can just use Pythagoras. So you haven't done this for maybe a little bit of time, but you should remember, you definitely did it last year. So Pythagoras is a squared. So a squared plus b squared equals c squared. If you remember, A and B doesn't matter which way around they are, but C has got to be your hypotenuse. So C, the hypotenuse is opposite the 90 degrees. C has got to be your hypotenuse. So C squared has to be 190 squared. A squared, let's just say that A and B don't matter, as I said. X squared plus B squared is 150 squared. So take X squared equals, take away 150 squared off both sides, so 190 squared, take away 150 squared, and then you want x on its own, so square root the whole of the other side, so 190 squared minus 150 squared. Put that into your calculator, so x is the square root of 190 squared minus 150, which gives you, press S to D to put it into a decimal, so you get 117 if you round it to the nearest whole number. So x is 117 centimetres. For 7 part B, it's asking you to find, for 7 part B, find the angle BCA to the nearest degree. Angle BCA means draw from B to C to A. The angle that makes, so the bit in here, is the one you're trying to find. The next one is ABC, that would be trying to find this one. So you're trying to find the two angles of the triangle. So if we're going to try and find the angle BCA, we're trying to find this angle in here, let's call that Y. So for 7B, you've now can label, now we're trying to find angles, it's to do with trigonometry. So you've got next to the Y, so you've got your adjacent, we've already labelled hypotenuse as 190. So adjacent and the hypotenuse, you're using cos. So cos theta equals adjacent 150 over hypotenuse over 190. Remember, this is finding the angle, so you're trying to find the angle y, so that should be a y rather than a theta. So I didn't write down the formula, so cos y equals 150 over 190. Then you're trying to find y, so you could take the inverse of cos off both sides, inverse cos 150 over 190. And you get y equals, so shift cos and press the fraction button, 150 over 190. And your answer is 38 degrees if we do it to the nearest degree. Okay, so you now know that y is 38 degrees. For 7 part C, it's asking you to find the angle, let's just do another colour, it's asking you to find the angle ABC. So that's A to B to C. Find the angle A to B to C. So you're looking for the green angle up there. The easiest way to do that is not to use trigonometry at all. The angles in a triangle equal 180. You should know that. The angles in a triangle sum to 180. So we've got 180. We've already got 90 and we've already got 38. So 180, take away 90, take away 90, take away the 38 of the answer you've just had. 90, take away 38, gives you 52 degrees. So rather than using trigonometry, just use the fact that the angles in a triangle add up to 180 to do that one. If I do question 9 now as the last one, okay, so question 8 as well, just while we're here. Question 8, you have to use a bit of Pythagoras to find DE first of all, so using Pythagoras there. If I do question 9, let's just get this whole question. So for question 9, you're trying to find the cross-sectional area of a shed is a trapezium. So that means sort of if you looked at a shed at the side, you'd get a trapezium. The taller side is 2.8, shorter side is 2.4, and the distance between them is 2.5. That's just showing you what's drawn out. Find the angle of the slope with the roof with the horizontal. So you're just trying to find the angle that's marked as x in here. So if you can imagine, you've got a triangle that's like this, and that would be 90 degrees. You've then got a triangle, the green triangle that I've drawn on here is 90 degrees. So what you could then draw, if you draw this triangle out separately, you've got x, that's a really rubbish drawing, sorry. You've got x in here. You've got the bottom side here is the same as this side here. The side length here and here are the same. So that will be 2.5 meters as well. You've then got the other side that you can find out. The hypotenuse of this triangle, we've no idea what that is at all. But because we know that this bit here is 2.4, we then also know that this bit here is 2.4. So this length here is 2.4. Let's do that in yellow. This bit is 2.4. We know that the whole length of the whole side is 2.8. So this leftover bit must be 0.4 for that top bit there. Now we've got a triangle, we can just do the normal trigonometry that you're used to. Across from the angle, that's the opposite. Next to the angle is the adjacent. So O and A, you're using tan. So for 9A, tan theta equals opposite over adjacent. Put in the values that you've got. So tan of x equals opposite 0.4 divided by adjacent 2.5. Inverse of the tan, so tan minus 1, shift tan when you're using a calculator, 0.4 over 2.5. Type that into your calculator, so shift tan, fraction button, 0.4 over 2.5, and you get an answer of 9.09. So if you do tan minus 1, 0.4 over 2.5, you get 9.09. That's the size of the angle. Okay, for part B, we're trying to find the length of the sloping roof. So you're trying to find the length here, you're trying to find this as y. Either you can use the x and use your angle and do trigonometry, but actually Pythagoras is probably a little bit easier here. Y is your hypotenuse. Because you've got three sides, you've got this side that you know, this side that you know, and this one that you're trying to find out, you can use Pythagoras. So a squared plus b squared equals c squared. C squared we know is the hypotenuse, so that's going to be y squared. A squared and b squared don't matter which way around, so 0.4 squared plus 2.5 squared. You want y on its own, you don't want the squared, so square root of 0.4 squared plus 2.5 squared. Work out what that's going to be. And you should get, press the S to do button, you get y equals so 2.53 equals y. And that's all you had to do for that exercise.